We're going to look at some more volume problems. Now we're going to focus on cylinders. If you all remember, when we looked at surface area, we said that cylinders aren't technically polyhedron, meaning closed three-dimensional solids all made up of polygons, but essentially they're pretty much like circular prisms. They're not exactly, that's not technically a true statement, but that's the basic idea. It acts just like a prism. The only difference is my bases now are circular instead of polygonal. So since that is the case, the formulas are going to be identical. The formula for volume of this is still going to be area of base times height. The only difference is how you calculate that area of your base. Here, since we're using circles, we're going to use pi r squared for area of the base instead of 1/2 perimeter times apothem, or 1/2 base times height, or 1/2 parentheses b1 plus b2 close parentheses times h for a trapezoid. Yes, all of those things from chapter 11, you have to remember those formulas. They're not going to go away. You got to know them. And so that's why I like you to write them out every time you use them. It just helps you remember them without doing very much work at all. Okay, so we've got this prism here, cylinder here. We have circular bases. Our radius is 15. Here's our height. So our volume is going to be, or before I do volume, I'm going to do area of my base, just to start things off, pi r squared, which is 15 squared times pi. And so that would be square meters, so area of our base. Now all we need to do is take that thing and multiply by the height. So volume is area of base times height. 15 times 225 pi, and I believe I have my calculator. I said I would find it before the next video. Let's see. I do have my calculator. Alright, so that should be 15 times 225, 3375 pi. And that would be cubic meters. Now this is the exact answer. That's how we would leave it unless they tell us to round. If they tell us to round, then we can actually use that pi button on our calculator, and that comes out to be approximately 10,602.9 cubic meters. So this is an estimate, that's an exact. So just be really careful. If they want the exact one, you leave it with pi. If they tell you to round, well, you just round however they tell you. This next one, basically the same problem, just different values. We have our height. They gave us the diameter. Just make sure you remember radius is always half that. So that would be an 11.4 radius. So area of the base on this one would be 11.4 squared times pi. And your volume would be that number times 18. And let's see what that comes out to be, times 18. If you leave it in exact form, that would be 2,339.28 pi cubic centimeters. And if you want to round off, if it tells you to round off, use that pi button. If you use 3.14, it'll be really close, it just won't be the same. It's about 7,349.1. So exact answer, estimate answer. All right, so this was nice because we basically had everything we need. We had the radius or the diameter, we had the height. Awesome, piece of pie. Now, whenever we don't have everything we need, we're going to have to remember some stuff from previous chapters. So for example, on this one here, I do not have the height. They're telling me find the volume of this cylinder. Well, I need area of base. I can do that. I can get the radius. But then I don't have the height. So what we need to do on this one is identify what is our height. So equals question mark. Any guesses? Maybe another right triangle problem. So h squared plus 12 squared equals 13 squared. just using Pythagorean theorem. What's that going to be? 169 minus 144. I think that comes out to be 25. So not drawn to scale, but we can still find that height. Now that we have our height, we have everything we need for our volume calculation. So volume is capital B times H. So that's going to be, well, the base is a circle and the radius is 6, since it has a diameter of 12. It's going to be 36 pi times 5. Let's see, that's 150 and 30. I believe that's 180 pi cubic feet. And just like always, if they tell you to round, you can go ahead and use that pi button on your calculator if you want to. If you use 3.14, I don't know how many times I can repeat it, but 3.14 is close to the value of pi. It's not exactly pi, so your answer will be a little off if you use that. This comes out to be approximately 565.5 cubic feet. And so I think that's good enough practice for now on those volume ones. I'm going to post another set of practice problems for my honors students. For my regular kids, this should be enough. One thing I want to end on is kind of like, what's the motivation behind all of this? Why? Why in the world would we study volume? Okay, well, volume is the amount of space being taken up. If you're shipping things in containers, they can only hold so much. If you own a company that bottles soda, like if you're in charge of Dr. Pepper, those cans can only hold so much Dr. Pepper. Volume is like probably one of the most important things that we can measure, and it's one of the most used things that humans, I should say, one thing that humans use the most. We look at volume in terms of weight. Also, whenever you go on an airplane, you can only have a suitcase with these dimensions. They've calculated the allowable volume that they have to move your stuff with you from one airport to another. So volume is, I would argue, probably the most useful thing that you can get out of a geometry class. Calculating that volume is really, really, really important. Also, if you're going to get into engineering, if you're going to get in, maybe you're going to be like an automotive engineer, looking at the volume of the cylinders, that kind of helps you figure out timing, it helps you figure out horsepower. I mean, all of this stuff is just interrelated. So I'm going to end there, and then for honors kids, I'm going to post one more video.